Morning. Can you guys hear me?
Yes, sir. Good morning.
Yes, sir.
Okay, so let me just check your attendance. Okay. Well, there's only a few right now, so I can just check your names. So again, make sure to use your real name. Pagbilao, Ortesa, Bayubay.
Present, sir.
Ortesa. Okay, there you go. So you can see my screen so that you would know that I'm checking your name right now. So overdose again. Bayubay, Lumasi, Salvador, Pagbilao. Pagbilao. And Kile. Okay. The rest, they were absent.
Sir, present by sir.
Liza. Okay. All right. So, who else was even was present? Okay. Pagbilao, Salvador. Okay. 2, 4, 6, 7. So right now there's only seven of you guys. Okay. That's okay. So let's proceed now to the. We're done with logarithmic function, right? So we were able to finish this one yesterday, correct? Up to this part.
Yes, sir.
Okay. So let's solve this one once again. Okay. Because I mentioned that the others answer were in the expanded it this one into y minus 3 plus 8 or minus 8. That one was actually also correct. Okay. So just realize that that one is also correct. Okay. So let me just show to you guys the other process. So again, getting this one as your u, y squared minus 6y plus 1. Okay. So this one can be transformed into y minus 3, correct? And then for this one, it's minus 9 plus 9 minus 8, correct? So do you guys still remember your u? And then the derivative of this one, if you're going to derive that one entirely, okay, of course you can do that one by parts. So it's like derivative of y minus 3 squared minus a derivative of a constant 8. Okay, so when deriving this one, it's actually, the same with the n minus 1. Okay, so bringing down the 2 and then y minus 3 and then deriving, that is the one that is inside. Okay. So derivative of y minus 3. So this one is equal to 2 times y minus 3, and then derivative of y minus 3 is 1. Okay, so that's for the first one. The other one is the derivative of the constant. And if you're going to add this one, of course, derivative of any constant is 0. So if we're going to simplify this, the du is 2 times y minus 3. Okay, so if we are going to compare now this one here, it's now quite similar. We just need to use a balancing factor since we need to eliminate the 2. It's now 1 after the balancing factor. So as a result, just follow the formula. So it's 1/2 ln of y squared minus 6y plus 1 plus c. So don't worry, I already recorrect your papers yesterday, so I also recorrected my record, my grade score record. Okay, so yeah, for those who answered this one, well, some of you answered this one as it is, and then some of you answered your u as y minus 3 squared minus 8. As long as your u is this one, then your answer will be correct. Okay, so are we clear so far? So again, this formula came from u raised to n. Okay, and then it's n u and then derivative of u. Okay, so this one came from the calculus one. I don't know if I was able to show this one yesterday, but it's in here. Okay, this one. So u is a function which is similar to, okay. So in here, if we are just going to derive as this one, okay. Notice that this is our u, this is our n, and then this is just an excess. Okay, you can just derive that one via a constant, this one. Okay, so bringing down the n, which is now this one right here, and then this is your u, just copy it as it is, as it's being dictated in here, and then reduce the exponent by 1. So from raised to 2, it became now raised to 1, and then the derivative of the u, which is y minus 3. And derivative of y minus 3 is 1. Okay? So I hope I was able to correct my mistake yesterday today. Okay, so are we clear now with your seat work? This is your seat work number, is it number 3 or 4? Can you guys follow so far? I'm not really sure if you guys are there, or just at least give me a thumbs up if I'm trying to confirm something. Okay, para naman hindi parang wala akong kausap. Okay, thank you so much for your responses. Anyway, I hope we are clear with this one. Okay, so I appreciate your effort for giving me a thumbs up. Okay, so we're done now with the logarithmic. So let us proceed now to the next module, okay, which is the partial fraction. Okay. All right. So imagine that we are inside a class. It's just that we are in an online discussion. So it's the same thing. You're looking at the screen, and then this is what you will see on the projector. So we are now on the Unit 5, Integration by Partial Fraction. Okay, so the unit learning outcomes of this module is to familiarize the process. You'll be able to familiarize the process of partial fraction decomposition. Then you'll be able to integrate problems with partial functions. So just a recall, okay, so an algebraic function such 3x plus 5 over 2x squared minus 5x minus 3 as can often be broken down into simpler parts called partial fractions, specifically this one. And then the process by having multiple fraction or multiple terms like this is a so-called decomposition. So that's why you will hear sometimes that it's called partial decomposition or partial fraction decomposition. Okay, it's like it's being decomposed into many expression or many terms. So this one, the equivalent of that one is just this. Okay, so they are just the same. So if you're going to cross multiply this two, okay, you will get the same exact as this one. Okay, but of course, the step in getting the 2 and 1 is a different you know different thing. Okay, it's a different way. Okay, like initially you can get this one. This was just a factorized version of the 2x squared minus 5x minus 3. So this one can be divided into two terms or two expressions. It's x minus 3 times 2x plus 1. So multiplying this one side by side, you will get this one. Okay, but for the 2 and 1s, it's a different process already. So it's a longer process. So it's like this one, initially this is just A, and then this one is B. Okay, so I taught this one in EngMath, right? You guys still remember in EngMath, the partial fraction?
Yes, sir.
Okay. So yeah, anyway, as long as you can remember, it would be easy to understand later on. So for now, again, this is the polynomial. Let's say numerator denominator polynomial, and then divided into partial fraction. So an algebraic fraction is a fraction in which the numerator and denominator are both polynomial expressions. A polynomial expression is one where every term is a multiple of a power of x, such as 5x raised to 4 plus 6x cubed plus 7x plus 4. Okay, so remember in EngMath that we have the so-called monomial. It's just one, and then binomial is two terms, trinomial is three, four is, let's say, well, actually three and above is called polynomial or multinomial. So this is an example of a polynomial. So the degree of a polynomial is the power of the highest term in x. So in this case, the degree is 4. So that is the highest degree to be exact. So the number in front of x in each term is called its coefficient. So this is the degree. Okay, this is raised to 3. We have a missing raised to 2. Okay, raised to 1 and then raised to 0. Okay, so of course, you guys already know that this one is a so-called coefficient of that degree. So the coefficient of degree 4 is 5. The coefficient of 3 or raised to 3 is 6. The coefficient of raised to 2 is 0. The coefficient of raised to 1 is 7. So when it's actually the coefficient of x raised to 0 is just simply 4. Okay? Now, consider the following algebraic fraction. So we have this one as the first one, and then we have this one as the second one. In both cases, the numerator is a polynomial of a lower degree than the denominator. We call this proper fraction. Okay? Oops, wait. Nag-pause ako kasi, inaapakan yung keyboard eh. Anyway, let's go back here. So remember the so-called proper fraction. Okay, let me just give you a few examples. So is 1/2 a proper fraction?
Yes, sir.
Is 8 over 4 a proper fraction?
Improper fraction, sir.
Why is that?
Numerator is larger than the denominator.
Yeah. So in this case, if you're going to simplify this one further, this would give us 2. And then of course, 2 is not a fraction anymore. It's now like a whole number already. Well, one half is one half. We cannot simplify it further. Okay. So this one is a proper fraction because we have a bigger amount at the denominator. So the same thing here. So we have a higher exponent, higher degree of exponent in our denominator. That is why this and this is an example of a proper fraction. So in terms of variable, for example, it's x cubed plus x squared over, let's say, x squared. Okay. So is this an example of a proper fraction? Anyone? Uh, Baisa,
Sir, pakiulit yung tanong.
is this an example of a proper fraction?
No, sir.
Why?
Because the numerator has a higher what is exponent?
Higher degree.
High degree, sir.
Yeah, that's right. And at the same time, this one can be simplified into x cubed over x squared plus x squared over x squared. And then again, if you're going to simplify this, it will give you x only and then plus 1. And then notice that this is not a, a fraction anymore. It's just a two-term. Okay, it's just a binomial. Okay, so the learning here is that a proper fraction is will stay in a fraction format no matter what will happen. Okay, you cannot simplify it further unless or unlike rather unlike the this one, this kind of fraction, which can be simplified further and then eventually that it's not a fraction anymore. Okay. All right, so let's proceed now to the next one. So in this section, we are going to take a look at integrals of rational expressions of polynomials. And once again, let's start this section out with an integral that we can already do so we can contrast it with the integrals that we'll be doing in this section. Okay, so this is an example of a proper fraction, correct? So x minus 1 over x squared minus x minus 6 is an example of a proper fraction, correct?
Yes, sir.
Now, notice that what happened here is not actually a proper fraction. Not a partial fraction. Okay, so not all proper fraction will lead into a partial fraction like uh this one. Okay, so in this example, you can actually check first the logarithmic formula. Okay, the du over u. Okay, so notice that if you're going to get this one as your u, okay, this one as your u, and then deriving that one will give us 2x minus 1, which is the same now with our numerator. Okay, so as to why we can apply the logarithmic formula, the du over u. It's working u du. Okay. So you can just use that one and then, you can just now, of course, use the formula. So the answer for this one is now ln absolute value of x squared minus x minus 6 plus c. Okay? So that is one thing that I would like you guys to do. Every time that you will see a proper fraction, check first. Maybe a logarithmic formula will do. If not, then that's the time that you can proceed to the partial fraction method. Okay, so let's have another example. So, however, often the numerator isn't the derivative of the denominator or a constant multiple. For example, consider the following integral. So this is an example of a proper fraction because we have a degree of raised to 1 and here we have a degree raised to 2. And then, of course, there's no harm in trying to check the derivative of your denominator. The derivative of our denominator is 2x minus 1, correct? Seems that
Yes, sir.
Pas Iwen is answering. Pero wala akong naririnig eh. Could you try to speak again, Mr. Dash? Wala nga, wala. So, try to recheck your audio, your mic. Okay? So, wala kaming marinig. Para pag nag-recite ka, malaman mo. Okay, so recheck mo yung mic mo. Okay, anyway, so in here, the derivative of x squared minus x is 2x minus 1, which is not the same with our numerator. And then there is no way that we can make them the same. Okay, so our next option to this one is, of course, now the partial fraction. So what we can do is we can transform this one or factor this one into x minus 3 and then x, magsulat x minus 3 and then x plus 2. Okay, so multiplying this one to each other would give us this one. Okay, and it's just a matter of finding the a over x minus 3 plus b over x plus 2 later on. Okay, so in here finding the a and then finding the b. And we will have that one later on. Let's just say that for now, we were able to, find the values of your a and b, which is now 4 and then -1. So in here, you can now do integration by parts, of course. Okay, so the derivative of x minus 3 is just simply dx. Okay, so logarithmic formula will apply to this one, so you can just bring this one out. Okay, so as a result, that would give us 4 ln x minus 3. Same thing here. So the derivative of x is dx. So I can just bring this one out. So the result will be negative ln x plus 2 plus c. Okay, because we have a working u du for each term. Okay. Now, this process of taking rational expression and decomposing it into simpler rational expression that we can add or subtract to get the original rational expression is called a partial fraction decomposition. So many integrals involving rational expressions can be done if we first do partial fractions on the integrand. So let's do a quick review of a partial fraction. We'll start with rational expression in the form of this one, f of x equal to p of x over q of x, where both p of x and q of x are polynomials and the degree of p of x is smaller than the degree of q of x. Recall that the degree of a polynomial is the largest exponent in the polynomial. Partial fractions can only be done if the degree of the numerator is strictly less than the degree of the denominator. That is important to remember. Okay, so once we've determined that partial fractions can be done, we factor the denominator as completely as possible. Then for each factor in the denominator, we can use the following table to determine the terms we pick up in the partial fraction decomposition. So of course we have a lot of format for the denominator, and then they can be a factor, or sometimes they cannot be factored anymore, like for example ax plus b. Okay, so this one cannot be factored anymore, so it will, it will stay as it is. So just find the a, it's just one term, so it's now a over ax plus b. So in some cases, we have repeated roots, okay, or repeated function in our denominator. So it's ax plus b. So if it's repeated twice, then you will stop right here. If it's repeated thrice, then just add one more. It's a3 over ax plus b raised to 3. Okay? So if it's repeated up to 5, then we have, 5 letters to be exact. Okay? A, B, C, D, E, F, or A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. So you can use any of those, if you want to stick with A, with a numerical sub number, it's A sub 1, A sub 2, it's fine. If you want to use just A, B, C, D, E, F, then it's also okay. Okay? So in here, that depends on how many is the repeated number in here. So for example, it's repeated by 10, then of course we're going to have 10 letters. Okay, so I hope we are clear with this format. And then in some cases, we have a polynomial. Okay, not just a binomial anymore. Okay, so in some cases, this one is not factorable, so you can just stick with this one. Now, notice that we now have a squared in here, so we will now have a different format in our numerator. So it's now ax plus b. It's not just A and B and C anymore. Okay, it's now a combination of two variable in one single expression. Okay, so it's now ax plus b. Now we also have, of course, if we have one only, we also have repeated roots of this raised to 2 denominator. Okay, if it's raised to 2, then you will stop right here. If it's raised to 3, then just add one more. Okay, so it's now plus a sub 3x, plus b sub 3 over, still the same, it's still ax squared plus bx plus c. However, your exponent now is raised to 3. Okay, so were you guys able to follow so far?
Yes, sir.
Okay, so thank you so much, Miss Pagbilao and Dash, for being attentive. And to Mr. Galutan also. Okay, so we have more properties that you guys need to learn. Okay, not really memorize. You just need to understand the concept. So number one, we have 2. Then it's just a matter of having 2 letters as well. Okay, it's a over x minus a plus b over x minus b. So we have a repeated roots. Okay, just like what I mentioned a while ago. This one is raised to 2. Then we will be having 2 partial fraction to be exact. So the first one is just raised to 1, and then the second one is raised to 2. Okay. Oops. And then for the third one, we have 3. Okay, but it's not non-repeated. Okay, so we're going to have 3 letters as well. A over x minus a over b over plus b over x minus b plus c over x minus c. The next one, the number 4, is the combination of a repeated roots and then non-repeated. Okay. So in this case, just follow the step 2 and then step 1. Step 2 first. So a over x minus a plus b over x minus a squared plus c over x minus b. Okay, so just always go with, from A to C. Okay, this one could actually X, Y, Z, but normally we use A, B, and C for the partial fraction. And then let's say a sub 1, a sub 2, a sub 3 for the partial fraction also. Okay, but x, y, and z, well, you can use that one, but it's not normally being used, okay, as a variable. And then number 5 is one non-repeated. That is just a binomial. And then one non-repeated as well, which is a trinomial. Okay, so the same thing. This is a combination of the first one, and this one is a different like a format. Again, once you saw a denominator that is raised to 2, that would give you 2 letters in the numerator. So the first one is a over x minus a plus. So the next letter is b, so it's bx plus c for the second denominator, or for the second term. Okay. Now, usually this x squared plus bx plus c here cannot be factorized further, meaning that's already its simplified version. You cannot do anything about it anymore. Okay. So if that is the case, then you have to use this format. But if you can still factor this one out into something like this, or even this, or this, then you have to use uh, form number 1, 2, 3, and 4. Okay. But if not, then you can just stick with number 5. Okay, so are we clear so far?
Yes, sir.
Yes, sir.
Okay, so we'll stop here for now, and then I'll just announce again the part 2 link, since we don't have that much time anymore. So see you guys on the part 2. So just join right away. Any formula? I'll answer your question later on, Miss Dean La Nathan. Okay, well, for now, we'll end our meeting since we don't have time anymore. Okay, okay, goodbye, and see you guys on the part 2.